This is AP Calculus, Unit 11, Lesson 2. We are on Standard W still. Standard W, again, is talking about areas. So yesterday we did the area between the x-axis and a curve. Today we're doing the area between two different curves. Where are we in our unit? So we're on our second lesson out of the 5, and then we're going to go on to volume from there. I know there's going to be quite a few of us gone tomorrow, right?
Yes.
I'll make sure to give you girls the worksheets today, and that video will be uploaded. All right, so we are talking about the water tank problem yet again. It's a good problem for an example. So we have it entering the tank at a solid 3 gallons per hour, doesn't change, but it leaves at this variable rate of x squared minus 6x plus 11 gallons per hour. So I want to know what the total change is between 2 and 4. So normally what we do is we look at both of those functions. So what do those functions look like? We have a constant function. I know, I'm getting fancy now, right? I have a constant function of 3. It's just a flat line.
How long are these notes?
These notes are 2 slides. They're pretty short.
You want us to draw them?
Yes, go ahead and draw those. So the important points that we need to have are 2 and 4 on our graph, and you know that the line goes at 3. And then we're also going to graph x squared minus 6x minus 11. This is what it looks like. Notice that it goes through the points 2, 3, and 4, 3, which is a nice parabola because it intersects at nice points.
What are the points we need?
Notice that this parabola has 2, 3 right here, and it intersects another lattice point at 4, 3. Lattice point is a fancy way of saying it goes through an integer point. Integer x, integer y.
Okay.
All right, so what we're going to do is we're going to combine those two graphs. I guess we could have written them at the same time, but you know that those are the two rates. If we combine them into one graph, we'll have this graph. So I want to find the total change between 2 and 4. So what I'm really going to be looking for is this combined area. And this combined area, we call this, we'll just say that's going to be the total change. So we'll say the total change R.
And that's what we're looking for?
And we'll label it R. Yeah, that's what we're looking for. Capital R.
Yeah.
Why are they negative on this side?
Why are they negative?
Look at the graphs, how it's like -1, -2, negative on the y-axis.
Those, it's the line that's going through them. The line is continuing through. That's not a negative one.
Okay, I was like, why wouldn't I just put it like...
All right, so that total change R, and maybe I should have the total change R up a little bit.
Distracting.
The total change R.
You're so rude. I'm trying to catch up and like.
So that is going to be, R is going to be, I can draw that nicer. R is going to be equal to the integral from where to where?
My drawings are really bad, Mr. Snow.
That's okay.
From 2 to 4?
2 to 4. It's the intersection points, exactly. From 2 to 4. And then we always do the top function minus the bottom function. So the top function is going to be what?
The first one.
Top function is going to be the first one. Yeah, it's going to be that 3. So we're going to say 3. And that's going to be subtracting our other function. Our other function.
Slow down for 1 second.
Yes.
I'm like still trying to number my
So
graphs.
what are, those arrows are pointing to 2 different functions, and then R is the... Okay.
Yeah, these two graphs combine to form this graph R.
Yeah.
Okay, so I have the integral between 2 and 4, mainly because that's where the points intersect, but it also happens to be the interval that it's asking for, 2 to 4, so it just happens to be the same.
Wait, I'm really confused with like those 2 arrows.
So I'm just saying that this graph and this graph combine to form this graph.
Oh.
All right, so
Really than I expected.
now that we know that, it's the integral between 2 and 4, and then I'm going to do the top function minus the bottom function. The top function, Joy told us, was 3. The bottom function is going to be what?
X squared minus 6.
X squared minus 6x plus 11. And I can move this so I have a little bit more room. And I need to be careful here because it's all of 3 minus all of this function, so I'm going to put parentheses around that second function. And then what I need to say is take all of that and then all of that dx. So I need to put brackets at the beginning. I can do a better bracket than that. Bracket at the beginning, bracket at the end, and we're going to say dx.
Wait, so you know what I was thinking about last night? Like I was trying to fall asleep, but instead I was thinking that like we haven't been putting plus c on anything.
That's because we're doing definite integrals. If you do indefinite without bounds, then you always do plus c. Yeah, if you want to refer back to the notes, there was a rationale that I explained why definite integrals never have a plus c.
AP count. I was
No. Did you not just embrace that she thinks about AP Calc before she goes to sleep?
Thank you for thinking about our class. I really do appreciate that.
Just like,
All right.
it was just going over my head. It was like I think about the
I was doing some practice problems.
So how do we calculate this thing? I want to calculate this thing by hand. And before I move too far, I want to make sure that we have a solid understanding of what's happening here. So what we had, let's do this a little bit bigger. I had this positive rate between 2 and 4. And I had this positive rate between this negative rate between 2 and 4. So everything in here, that was represented with a positive, everything here is a positive area. Everything here, this area over here is a negative area. This is the total positive change, total negative change, and we can subtract them just by looking for this area right here. So we see what's happening?
Yeah, that makes so much sense.
All right, so let's go ahead and calculate this guy. So what I'm going to do is I'm going to grab him. We're going to calculate him by hand without using the calculator. So I'm going to copy and go do a new slide here and paste. Okay. No. I'll paste and move him over so I can grab all of him. All right, I don't want the arrow though. So let's grab all of you and move you to the top. Okay, I have some black space because the resolution's all messed up. But how do I calculate this guy? So let's simplify. So this is going to be simplified into still the integral between 2 and 4. And now the inside is going to be, I'll just leave normal parentheses. What am I going to have? Someone help me out.
3x?
Not exactly. We still have, let's go by descending order. So let's do all the x squareds first.
2x.
All the x squareds first.
What? What are you trying? X raised to the power of 3 divided by 3.
So this is a 2 right here.
2x.
So this is the negative is being distributed into each of these terms, right?
Oh. Negative x squared
Okay, so I have a negative x squared
plus 6x minus 1.
plus 6x, and then be careful here. It's 11,
Oh, that's an
Minus
11?
11.
I thought it was a 1.
so it's going to be minus 11, and then plus this 3.
Wait, shouldn't the
So,
3 have
minus 8.
Oh no.
Minus 8
I thought it was a 1. I wrote down a 1.
dx. Yeah, it should have been an 11.
So then
Only
technically
you.
plus 8.
So say that again?
Mine, yeah, never mind.
Oh yeah, so you're just repeating this? Okay, perfect. So now we're going to take the integral of each of these terms individually because they are all by themselves. So this is now going to turn into the integral between 2 and 4 of negative x squared dx. We're going to add that to the integral between 2 and 4 of 6x dx. And finally, we're going to add this, well, I guess you can say plus a negative, or I can just say subtract the integral between 2 and 4 of 8
No.
dx.
I'm saying.
All right, so let's test our antiderivative knowledge. Antiderivative of negative x squared is?
Taxman.
Do we need taxman? Good question,
There's
yes.
a negative 1 in front.
So taxman, what is the u?
2.
Yeah,
No,
negative
And
1.
0.
no.
Negative x.
What is the inner? Inner is the x. What is the dinner then? 1. Do we need taxman?
No.
No. All right, so
Literally solved.
go ahead and do the antiderivative then. This is going to go up a power, divide down.
So negative x.
2 divided by 3.
Divide by 3, and that's the evaluation bar from 2 to 4. Perfect. Next, antiderivative. Go.
3x squared.
3x squared. An evaluation bar, 2 to 4. And then we're going to subtract here. What is this going to be?
Negative. Sorry. Is it 8x?
8x.
So, yes, you are correct. It is 8x, but there is a shortcut. Does anyone remember the shortcut for doing this?
8 times 4 minus 8 times 2.
That is close to the shortcut, but you do 4 minus 2. So this is going to be 4 minus 2 times whatever this number was. Whenever you have the integral of a constant, it's always going to be b minus a, 4 minus 2 times whatever the constant is.
You're
So,
close.
so I'm going to do the shortcut here because I expect us to be doing the shortcut on the test as well. All right, so from here, I need to evaluate this. I'm going to plug in 4 and then plug in 2 and then subtract them. So first, let's keep that negative sign out front, negative. And then I have, when I plug in 4, that's going to be 4 cubed. So 4 cubed is
160. Oh, just 64.
64. 64 over 3. And I left that negative out front, so I don't need to worry with him. And then I'm going to subtract when I plug in 2. 2 cubed is? So I already have the negative out front, so it's just 8. 8 thirds. Perfect. And then I'm going to add this with evaluation for this one. So it's going to be, I'm going to leave that 3 out front, so don't worry about the 3. We'll worry about him at the end.
Wait, so wouldn't that be a plus then? Because you go negative and...
Right here is going to be, yeah, you'll distribute the negative, but I'm going to leave the negative out front for now.
Okay.
You are correct.
Yeah.
All right, I'm going to leave the 3 outside and then just evaluate with x squared. So 4 plugging in gives you 16. I'm going to subtract 4. Perfect. And I left the 3 outside. I'll distribute that at the end. And then this is going to be subtracting. Simplify this. Give me the number. 16. Perfect. All right. Simplify this fraction, and then we'll multiply by the negative.
I like backed out a little.
I knew it was going to be.
54
I didn't like it.
over 3.
I think that's why I heard.
Not quite 54.
Negative
56.
Yeah, it's going to be 56 thirds. And then I'm going to include this negative. And then I'm going to add that with, simplify this number. 36 minus 16.
20.
Perfect. And then 36 minus 16 is going to be 20. So this thing right here, I'll do this in a different color. This thing right here is 20. And then we need to have simplified fractions. So I need this 20 to be over 3. So it's going to turn into what over 3?
60. Yeah, 60.
60 over 3. And this is going to be still negative 56 over 3. And I'm going to add those. And my final answer is 4 thirds. Let's back up. What did we just find? We just found, in the context of the problem, too far back, in the context of the problem, is the total change in water between 2 and 4. It's 4 thirds, whatever our units were, gallons. Why is it not gallons per hour? Why is it not 4 thirds gallons per hour?
We're not finding a rate.
We're not finding a rate, but why are we not finding a rate?
We're taking the integral.
We're taking the integral. Whenever we take the integral, we're going backwards in the units. You're getting rid of time. You cross off one of the times every time you go backwards. If it was gallons per hour squared and we were taking the integral, you cross off the squared and you're left with hours. If you're just having hours, you cross off the hours and go to gallons. Whenever you go and take the integral, you go backwards, get rid of one of the times. Perfect. All right, so we found our answer, 4 thirds. Let's move on to...
In gallons of water. What?
So this thing should be gallons if you want to be exact.
Oh, bruh.
All right.
How much more is there, Mr. Snell?
This is the last slide, and it's just a graph with these 2 equations.
Alright, I can fit it too.
I thought it was 2 slides. It turned out to be 3 because I didn't realize how long that calculation was.
It's okay. Everybody
I get it.
So give yourself 2 curves, and they're going to intersect at point A and B. We'll say that blue function, we can call that blue function f of x. I should switch to blue for my color also. F of x, and we'll say that the red function, we'll call that g of x. So for this general function, the way that you always do this, and this is our key here, is going to be this. R, this area, is always going to be the integral between a and b of the top minus the bottom. So f of x minus g of x, we'll say, I can even color code this for us. F of x minus g of x. And then all of that needs to be multiplied by dx.
I'm just really hungry, I guess.
That's the general formula. But if you prefer, and this is the one that I always remember, you have a different type of integral that you can remember. The integral between a and b, top minus bottom. All of that in brackets dx. Both of those are great to memorize this lesson. If I could take one thing away and only put one thing in my summary, it would be this. But I would put both of these in our summaries and one other thing that you learned. That ends the lesson.
Can we say goodbye? Bye.
We're going to do example problems also, so
Hashtag
not quite
have
bye.
a good day.
Go ahead and do your summaries now.
Hashtag enough.
This is it.
This is our last.
All right, let's do homework question number 2. We skipped number 1. Number 1 is pretty straightforward. If you know how to do number 2, you can definitely do number 1. The homework problems that I'm choosing to do are number 2, 3, and 6 for our examples. So here's number 2, and I consider this kind of an easier type of question. The first thing that we need to do is we need to figure out what our bounds of our integral will be. We know that that bound will be between that point and that point. We know what the first x-coordinate is. That's just going to be 0. But we don't know this one. So this is what we're going to have to do. We're going to have to use our calculators and find that intersection point. So let's go ahead and do that. The intersection point.
Here we go.
So I do my y equals 1 plus sine of 2x, and my y2 is going to be second natural log to get e to the power of, and it's going to be x divided by 2. All right, so my window, a good window is, I don't know, 0 to 3, I guess. Where's my window? 0
How come when I'm
to
hitting
3.
natural log?
Zoom 0.
I'm really struggling today.
Wait, what's our window between?
0 and 3. It's just a guess. I don't know. It might end
What
at
if we
10.
do 0 to
I have to change it
100?
later. You can do 0 to 100 if you want, but I'm pretty sure these intersect pretty fast. Oh yeah, it's right there. It's right within. I could have done my window between 0 and 2 and it would have been fine. So we need to find the intersection point. Obviously, that one is going to be 0. I would hope it was 0. We can check that though. So I'm going to do second trace to get calculate, and I want the intersection point. So 5. So I hit enter, enter, and my guess. I'm going to guess 1. So I hit 1 on my calculator and hit enter, and it will give us
1.136.
yeah, 1.136. I agree. So we'll label that on our diagram as 1.136. And you can check that that's 0, but I trust that it's 0. They usually are. So now we set up our integrals. So we say R, that area, is going to be equal to the integral between 0 and
No room.
1.136. I had enough room. You just have one line that you have to write. And what we want to say is the top function minus the bottom function. So top function is f of x minus g of x. Don't forget brackets. Don't forget your...
dx.
Yeah, so don't forget your brackets. Don't forget your dx. Perfect. Now we have to do that on our calculators. Let's do that.
It's just that, like,
So the easiest way to do that is probably just from our graph, although you could do it without the graph. You could enter y1, y2, but it's all right there. So what we could... Oh, maybe we can't.
No, I think that shows you're really smart.
I think...
Not think about math.
Yeah, so you can't do this from the graph unless you do y1 minus y2 for y3 and then graph that one. But I don't want to do that one. I think the fastest way to do that is to just do it from your main screen. So what I'm going to do is, how do I do the integral again?
Math 9.
Math 9. And what are my bounds? Or what function am I going to do?
Vars enter, enter.
Vars right,
Enter.
enter, enter. So that's y1. And is that it?
No.
What am I going to do?
Respect to x.
Nope.
Minus.
I want to do y1 minus y2. So vars right, enter 2. y1 minus y2. And then, that's with respect to x. What are my bounds again? 0 to 1.136. All right. Let's see what that gives us.
I got that.
Awesome. Yeah, that's what we should be getting.
Wait,
This should approximately be equal to 0.429.
That's it?
That's all we have to write.
I like was trying to save room.
I know, I was like, Why'd they give us such shiny stuff?
Every single problem in here, with the exception of the back, is going to be one line. On the back, you have to actually calculate using manual math where those intersection points are. You have to set your functions equal to each other. Let's look at a harder one. I want to look at number 3 and just talk about him. I don't want to solve him because we know how to solve number 3 already. But I want to talk about this type of function. On the AP Calculus test, on my test, on the practice test, on the actual test that you take in May, what they will say is find the area between here and here. Or sorry, here and here. They expect you to know, oh, hey, it switches here. I have to find the area of R and then find the area of S. Because g of x is on the top here. This was g of x right here. And then f of x is on the bottom. But that switches at this point, and f of x is now on the top, and then g of x is on the bottom. So you have to calculate them individually.
Nice.
That's all I'm going to say about number 3, and then I'm going to go on to number 6. That's why I had you calculate r and s individually. Just be ready for that on the test. S is going to be, or sorry, 6 is going to be a little bit difficult because they don't give you the start and end points. You have to calculate that on your own. You have to calculate everything on your own without a calculator.
Wait,
Number
can we
6.
do it together?
We are going to do it together. I'll give us a few minutes to try this out on our own before I begin. On to number 6. So we finally worked and then we got stuck. So first I need to find this x coordinate and then that x coordinate. So how do I do that? I set these two functions equal to each other.
Who said that?
That was me!
Woo!
So x squared is equal to 4. Therefore x is equal to which two coordinates?
2.
2 and?
Negative.
Yeah, so negative 2 and 2. Plus or minus 2, square root of 4. All right, so we know our bounds for our integral. We can say that r is going to be equal to the integral between negative 2 and 2. And then I do my top function minus my bottom function. So my top function was 4, so I'm going to say 4 minus, and then my bottom function is x squared.
That's what I said.
And then that is going to be with dx. And then I'm going to do the integral. But I want to talk about a little trick that you can use, and you use this all the way up through college level calculus. If a function is symmetric, if the right portion and left portion are equal to each other, you can simplify your math a little bit. Instead of doing this integral between negative 2 and 2, because I know that it's symmetric, I could go like this. I could say, well, from 0 to 2 is the same thing as negative 2 to 2 as long as you multiply by 2. I want to pause and really digest this. This is a shortcut because plugging in 0 is super easy compared to plugging in negative 2. I could have done the same thing from 4 minus x squared dx, only if it's symmetric. This was a parabola. I know x squared is symmetric. There are a bunch of other functions like sine, cosine, the trig functions, different types of powers that are symmetric. If you think it's symmetric, it probably is, and you can use this trick.
So shortcut if symmetric.
Yep, that's a shortcut. Let's go ahead and continue to do the calculation here. And I can show that both of these are the same. I'll run through the second one really fast, but let's do the first one nice and slow. So this integral is going to be applied to each of these terms individually. It's kind of like I'm distributing this integral into each of these terms. So when I do that, I get the integral between negative 2 and 2 of 4 dx. And I'm going to subtract the integral between negative 2 and 2 of x squared dx. All right. Integral between negative 2 and 2 of 4, that number is equal to what?
0.
Careful. You do 2
2
minus 2 times this.
So 16.
So 16. Then I'm going to do minus, and then I need to do this. So I need to take the integral of x squared. That becomes what? X cubed over 3. Evaluation bar, 2 to negative 2. I can move this out of the way. And I'm going to squeeze it in down here. So that's going to be 16 minus, when I plug in 2, that gives me 8/3, right? And when I plug in negative 2, what do I get? So this is going to be, I have to do minus because I'm going to do whatever's going to come next. And then plugging in negative 2 gives me negative 8/3, exactly. So minus minus, they kiss, the negatives kiss, so it becomes a positive. And on top of that, this negative is going to be distributed into each of these terms. But let's just combine those terms to begin with. So I still have that 16 out front. And 8/3 plus 8/3 is 16/3. So let's change this 16. Let me back up a little bit. So this is going to be minus 16/3. What is this 16 going to be turned into in order to be divisible by 3? Or if you know the shortcut to just get to the final answer, that works too.
16, whatever 16 times 3 is.
48.
48/3, yep. And then 48 minus 16 is 32/3. Perfect. Let's see if we get the same answer doing the other way. So the trick here is if you know that you're doing 16 minus 16/3, it's the same thing as doing like 1 minus 1/3. You'll really have 2/3 of whatever that answer was. 2/3 means you multiply by 2 and divide by 3. 16 times 2 is 32 divided by 3. That's the little shortcut if you want to try that one. Math is full of shortcuts. That's technically what all of math is. I'm showing you the shortcuts of doing all of this calculus. And I'm going to go on a brief tangent here. Doing calculus is different from doing the calculus, and this is some fundamental stuff, I guess, that we're talking about in math. Doing calculus in general means you apply the set of rules on top of all of these equations, and each problem is a brand new problem. This is what happened before Isaac Newton came around and started getting calculus turned into, or turning the calculus into calculus. And then eventually we had people that came along like, oh man, I'm blanking on the name. Who was the guy that had the battle between Newton? It was Newton versus Leibniz. And then Leibniz got all the notation for us. And now we can apply this over and over, and now we just have calculus. Calculus is easier than the calculus. Weird tangent. Coming back. Let's do this one really quick. So if I do this one, it's going to be, so I'll leave that 2 out front. I'll worry about him later. So integral between 0 and 2 of 4 is going to be 8. And then it's going to be minus x cubed over 3 evaluation bar 2 to 0. When I plug in 2, that's going to be 8/3. So this thing now turns into 2 times the quantity of 8 minus, when I plug in 2, it's going to be 8/3. And I know using the trick before, it's really going to be 1 or 2/3 or whatever that number was. So that's 16/3. So it's going to be 2 times 16/3. And I have 32/3. Again. A little bit shorter. You didn't save too much time because this was kind of a straightforward problem, but harder problems, there's really great math that you can avoid by taking that shortcut. That's the last homework problem that I wanted to go through. Number 5 was also kind of hard, but I will let you girls try that one on your own. All right, good luck on the homework.